Thank you. Let me begin with a quotation. This comes from the health warning due to unnecessarily gendered language, but I'll steam right on. Quote, by augmenting man's intellect, we mean increasing the capability of a man to approach a complex problem situation, to gain comprehension to suit his particular needs, and to derive solutions to problems. Augmenting man's intellect, in the sense defined above, would warrant full pursuit by an enlightened society if there could be shown a reasonable approach and some plausible benefits. When you think about augmenting the human intellect, artificial intelligence and large language models might come to mind. Large language models are, needless to say, machine learning systems designed to process natural language. Obviously, the top examples are ChatGPT, Claude, Gemini, and all our friends. Indeed, if we think about the project of augmenting human intellect, LLMs can do some relevant stuff. They can aggregate data, can make connections, help us understand data sets. So, however, where do LLMs fit into this project? And how should we respond to music? My outline, my overall response is very simple. I think that the biggest, most widely used large language models are causing a great deal of harm to our society and to us as individuals. And I think that the true study of the augmentation of the human intellect is hypertext. What am I going to talk about today? In part one, I'm going to talk to you about why I think we need an alternative, and talk about what that alternative should look like. And in part two, I'm going to show you what I've been working on, what it looks like in practice, and finally give you a vision for what I hope will be a better future for our society. Most of the ideas that I'm going to talk about today are old. They are not mine. So if I express an idea, I would assume that it's not my idea. And I'll try and remember if it is my idea, but I might forget, so I apologize. Let's therefore begin part one and consider the dream. Here are 3 reasons why I think we need alternatives to large language models. The first of the 3 reasons is that large language models, and particularly the biggest ones, some of the biggest companies, are extractive. You can see a simplified diagram of the economy of a large language model here on screen. At the top, you have the hyperscalers, the bajillion-dollar companies, and the bajillionaires who run. These people are absolutely coining it. And they're coining it in return for delivering a marginal improvement to the people in the middle. People using Claude to make code faster, people on LinkedIn, the marketers, using AI-generated images to help with their posts, etc. And then the people at the bottom, the precariat, the translators, writers, etc., these people are losing big. And they're losing big while everybody's telling them, you're like horses, and we're building cars. This is just progress. When, firstly, most of these people didn't ask to be a part of this. Their data is aggregated, often without their permission, and in many cases downright stolen. See the recent legal judgment against Anthropic. And as I mentioned, or by extension, this is not just normal inequality. So, for instance, take a burger chain, right? The CEO makes $1 million, the fry cook makes $15. At least the fry cook is paid. These people didn't ask to be a part of it. They're having their stuff aggregated. And I have been asked a grand total of 1 time whether an AI could use my data in order to build its model. By Medium.com as it happened. Secondly, an LLM might claim to tell you why it said something, or why it made a particular decision. This is different to actually knowing why. If it's a database, if it's a file system, if it's the web even, there's some disk somewhere or solid state storage that you can look at with bits on it. And those bits will give you at least some clue as to why you did it. Large language models are black boxes. Thirdly and finally, most people interact with large language models naturally via natural language. I love natural language. I'm speaking English now, I write in English. But natural languages have at least two problems that are relevant to us here. The first is that natural languages are always culturally specific and are therefore alienating to people from different cultures. And this is obviously good, cultural interplay is good, but we don't want it to be a barrier to people. Secondly, natural languages are usually very indeterminate in their interpretation. Compare TCP/IP and how trivial it is for me to connect this machine to the network, because that TCP/IP stack is well-defined, deterministic. Compare that, for instance, to the US Constitution in English, which is still currently being reinvented, and we're still today talking about what these words in English mean. Both of these things make it harder when you're using a natural language. They make it harder to build tools that allow people to work together, to build systems that talk to each other. We've spent decades of work building solutions to help people connect between cultures, between creeds, between nations. And I fear that these models are actually turning back the clock on some of that work. It's important to note that you can self-host your large language model. And you can use open source large language models. If you can, you should obviously do this. But at the same time, you should be judicious about the claims that people are making. How open source is your model, really? How can we prove that? Meanwhile, even if you were to build large language models that were free from the three problems that I talked about, we still need alternatives. Choice is good in and of itself. In essence, LLMs offer tools to help you do things, but when you pop the hood, all that tool is other people's data and a massive, massive amount of processing power. I ask the question, therefore, why don't we use some of this treasure that we're spending on these tools in order to build better apps to really augment the human intellect? To think about what this looks like in practice, we need to talk about Ted Nelson. In the 1960s, this man, Ted Nelson, who's still alive, figured out what the world of today would look like in computers. He talks about, for instance, talking about why we need lowercase text on computers. He's that old, he's been doing this so long. Many of his predictions came true. And to the extent that reality deviates from his vision, it's usually for the worse. Nelson had a much more humane vision of computing. He thought that links, hyperlinks, should be connections, should be relationships between pieces of information. They should be first-class citizens, they should be filterable, siftable, queryable, and especially that wherever you're looking, you should see the links pointing to that and pointing away from it. He thought that it should be trivially easy to combine any material of any type. For instance, I might want to take a paragraph from a PDF and a paragraph from an email and combine them into a document, which is impossible today if you have a requirement that those snippets should have a relationship back to their original context. Finally, Nelson thought that it should be straightforward to access information online, again, regardless of nationality, creed, affiliation, etc. But you should pay what you owe, and that we should have facilities to allow you to pay as you go. We were talking earlier about these incredibly expensive subscriptions to academic journals, thousands of dollars. Why can't I read as much as I need and pay by the bit? Microtransactions. This is Ted Nelson's idea. I say, therefore, choose wisely. Compare these two visions with the future. The LLM vision, which focuses value from the base, from we the people to the top, to these bajillion-dollar companies, aggregating data in a way that traps it in a black box, and which makes it harder to collaborate together. Compare this to Nelson's vision of a community of equals collaborating to build an interoperable information structure based on human solidarity. So how do we bring this vision to life today? Let me show you how. Let me start by quoting John Locke. Quote, "The active mind, wherein it exerts its power over simple ideas are chiefly these three: combining several simple ideas into one compound one, and thus all complex ideas are made. The second is bringing two ideas, whether simple or complex, together and setting them one by another so as to take a view of them at once without uniting them into one, by which it gets all its ideas of relations. The third is separating them from all other ideas that accompany them in their real existence. This is called abstraction, and thus all its general ideas are made, unquote. These ways of thinking give us our design requirements. The first requirement is identity. Everything that corresponds to a unique human idea should be uniquely identified. And if you have the identity of something, you can get in and no less the correct version thereof and not a bit more. The second requirement is recursion, meaning that the user should not have to switch apps to dig deeper into the same data, and that they should be able to embed anything in any other way. Reference the question about combining a PDF, a document, and an email into one. Finally, the user should be able to work in any number of dimensions, as they wish. For instance, when you're working with the World Wide Web, if you have a span of text, you can have one link on that span of text. A spreadsheet can be in 2 dimensions, 1 or 3, 4, etc. These are outdated restrictions that we should move on from. Because it adheres to these design requirements, my application Curious, I say, is shaped like human thought. Or more precisely, it's idea as in thought isomorphic. It's idea isomorphic, meaning that there's a one-to-one correspondence between Curious and its pieces and their structure, and there's a one-to-one correspondence between that and the human system, these pieces and the structure of the idea in mind. Idea isomorphism. So how do we organize the data? Put yourself in the 1980s. Imagine that you're Tim Berners-Lee at CERN. You're working on the World Wide Web. You know that links should be visible from all their endpoints. But you can't think about how to achieve this without a central database that you can query to get all the links that pertain to a certain thing. So you decide to make all servers and pages independent of each other. And you store the link in the web page. Now, you have to go to every other web page online to know if there are any links pointing to what you're looking at. And some of you may know that this is what Google does. Google crawls, it finds the links, and that's how it maps the internet. That's how it maps the web. This decision, made sometime in the 1980s by one person, shattered our information environment into 1 billion lonely pieces. And in my view, this broken information system is why modern discourse, in my view, is so broken. So how do we have a unitary data system without centralization? Here's my attempt to cut this Gordian knot. The first is that you have a single address space. Use UUIDs or some modification thereof. You, the user, are responsible for storing your stuff. And we, the community, are responsible for cross-cutting concerns. For instance, links that pertain to material owned by several users. How do we store it? In our model, everyone rents their own personal server, user-friendly personal server, which we call Envoy. They store their material there and some subset of the links that the community has. And while you have it, you may as well store some other handy information there, like your profile picture, like your bio, maybe even protected information that's useful to have in a cloud context, like your clipboard. These envoys work together to facilitate a network which we call a hypercosm. This network redundantly stores material and link, and the hypercosm lets you see how any one thing fits into the whole of human knowledge and ideas. And indeed, this system will allow you to visualize the overall structure of human thinking. Don't worry, I'm not one of those blockchain, guys. This isn't 2022. But yes, distributed ledger will be a part of this because it's a tamper-resistant distributed information system. But this is a tiny, this technology is a tiny, tiny piece of how to make this whole thing work. With these three elements, COIUS hypertext shell, Envoy personal server, and the hypercosm information system, you have everything you need to create, store, organize, visualize information while maintaining ownership of your data and while stewarding our data. Let me show you what this looks like in practice and then talk a little bit more about how we can build a better future here. Let me show you what COIUS can do. Now, part of this is going to be video and part of this is going to be app, so please forgive me for a little bit of user interface shuffling here. Now, let me see about the video. Excellent. On screen, we have two pieces of text here. And on the left here, you can see that each element is uniquely identified. And now I went into sentence mode, and you can see, moving a little quickly there, I went into sentence mode. I'm just going to have to continue this. And you can see that COIUS knows where the sentence begins and ends, which means that it's able to outline the sentence. And indeed, the sentence is uniquely identified, as is the paragraph. Now, this in to a small degree is what it means to be ideosomorphic, meaning there's a one-to-one correspondence between the elements and the, meaning that there's a one-to-one correspondence between the functional elements on the application, like the word, the sentence, and the paragraph, and the human constructs in the mind. A paragraph isn't like in Microsoft Word, where it's just a chunk of characters. A sentence is not like it is in Microsoft Word, where it's just a chunk of characters. A sentence is a uniquely identified chunk of information stored in my database. On screen here, we have the British Bill of Rights, 1689, and an extract from the Bill of Rights, 1789. And you can see that the word petitioning and petition are connected. That's because the British Bill of Rights influenced the American Bill of Rights in that respect. You can see when I pop open this link here, from speech, the word speech to expression there in the Constitution of Liberia. That's because Liberia, being deeply influenced by the US Constitution, it has that relationship. Now with COIUS, we can pull up our texts here, we can juxtapose them and intercompare them, and we can visualize the relationships. And note that this is natural language free. So these links here, I can say the Bill of Rights influenced the US Constitution in this respect, in natural language. But I can show it to you. And if you're a second language English speaker, this picture is still clear to you, because these lines are culturally universal. And note also down on the bottom left there, the links are listed. The links are uniquely identified and the links are addressable, which will become important in a moment. And what this allows us to do is look at texts like the Constitution of Liberia, the British Bill of Rights, the Constitution of the USA, and see how they've developed and see where they come from and understand how they fit in. Let me now show you how we can use COIUS to explore an information set. What I'm doing right now is exploring the tree of life. And you can see that the construct that I'm working with here is in fact tree shaped. Ideosomorphism. The idea of the tree of life is tree shaped, therefore the data structure that we work with should itself be tree shaped. So here we have the chordata and the hemichordata. The chordata group contains the vertebrates, and I've included here fish, amphibians, and reptiles. And I can open up an article, and I can keep navigating, I can keep exploring. Compare this to Wikipedia. Wikipedia has articles on all animals and groups and genuses, etc. in the tree of life. But it doesn't allow you to see the tree. And when you explore things on the web, typically you're put in this
weird full screen experience that doesn't allow you to have a few things up at the same time and to see where you are and to navigate and to orient yourself. Now you can see that I've opened up the article here on the vertebrates, which has fish, amphibians, and reptiles in it. I could also open up the single article on the fish, for instance. Now note that this is the same piece of content. The fish article is not copy and pasted from the article on the vertebrates. When I pulled up the article on the vertebrates, I was pulling forth all of those pieces and combining them together. On screen here, I'm going to show you an extract from a couple of Wikipedia pages. This is the Wikipedia page on the ideal gas and black body radiation. And now you can think of black body radiation as being radiation in a box. And you can think of ideal gas as being gas in a box or particles in a box. And the interesting thing is that these two systems are governed by similar equations. And Albert Einstein noticed this relationship between them. And he thought to himself, if these two systems are, one of them is particles in a box, and one of them is radiation in a box, and they're governed by similar equations, maybe these are similar systems. And that's how Einstein came up with the modern instantiation of the photon. And what I've done here is created a link between those two concepts on screen, and created a link from my little paragraph there on Einstein that points to my link. This is to say that COIUS allows you to create recursive data structures, to talk about relationships and to talk about analogies. Douglas Hofstadter, the philosopher, says that analogy is the fuel and fire of thinking. And I think that our systems are actually rather poor at displaying analogy. One final thing. The text here on the right is an extract from the Wikipedia page on the viable system model, which in essence discusses how you can build a system like a company or something like that that survives, that carries on by maintaining its internal state and responding to changes in the environment, which is roughly equivalent to the concept of autopoiesis in nature, which is when such thing as a cell or organism has these characteristics. I've created a link between those two things because they are, of course, analogous. And I've also created a link between the links because the analogies are analogous. Now, compare this to a large language model, which is creating all of these analogies implicitly, comparing and contrasting data, building up inferences, and putting them in a black box. Now compare that to what's on screen. It's natural language free, it's explicit, it's complete whatever you pull up and whatever you put down, and everything is on the disk and you can look at it. Every link, every inference, every analogy is stored and uniquely identified. And I can edit it, I can reference it, I can reprocess it, I can repurpose it. Ted Nelson's dream is possible. It works. You've seen it work. It's going to take a lot of feedback and collaboration to take us to the people, and I think that this is really important work. Having looked at COIUS and looked at what COIUS can do, let's consider what's at stake here. In my view, computer interfaces can be divided up into three eras. The first era was shaped, computer interfaces were shaped like computers. This image on screen here is of the front panel of an IBM 360, which allowed you to punch in individual bits into a word. See also paper tape, punch cards, to a lesser extent terminals. The second era was shaped like things. And this was a combination of probably embarrassment at how hard the first era was, but also a very pernicious form of prejudice. Computer people decided that non-computer people don't understand computers. They don't understand abstraction. We need to give them metaphors, like the trash can, the desktop, like documents. And in my view, these metaphors have turned into prisons. Part of the reason why it's so hard to intersperse, recombine, and remix documents is that we pretend that digital text has anything to do with paper documents, which it has nothing to do with. In my view, we're currently transitioning from the thing-shaped era to the thought-shaped era. And it's happening because of large language models. Large language models are making people realize that computer interfaces don't have to be stupid and don't have to be based on ridiculous metaphors. Large language models are making people realize that the computer can come to you and, so to speak, talk to you in your own language. And in my view, this transitional period is at risk of collapsing under the weight of its own irony. Large language models are our best friend and our worst enemy, in that they're waking people up to the fact that computers can come to you and that they can work with you. While at the same time, large language models are threatening to trap us in a new era of exploitation. Like back in the late 20th century with IBM and Microsoft, these large language models and the companies behind them are threatening to trap us in a new era just like that. Finally, we only think we need large language models because Tim Berners-Lee shattered our information and our ideas into a billion pieces. We only think we need machines and these models to make things make sense for us again because we blew it up in the first place. I therefore ask you to choose wisely. We got the second era of computing dead wrong. The mission here should be about augmenting human intellect. And the second era of computing was about pushing paper, controlling people, secretarial tasks. It was about fonts, when it should have been about structure. In the next era, we need to ask ourselves the question, do we want to live in a world, in a computer world, characterized by quick hits of information that are easy to understand but impossible to work with? Do you want to live in a world that's characterized by centralization of information at the same time as this division of people? And do we want to live in a world where data is ubiquitous, but where you can never actually get at it and look at the bits on the disk and decide what you think you should do? Or do we want to live in a world that's based on collaboration among equals, based on clarity, and tools really designed to help you think, and based on freedom? Or, if the third era, if the thought-shaped era of technology is going to be more like the second era, and if people like me stay in the minority, at least let's keep the dream alive, and let's build alternatives that people can use. Either way, let's build it. I invite your feedback. You can visit my website, email me, subscribe to my newsletter. I need feedback on the application. I need feedback on this presentation. I look forward to hearing from you. And I invite your questions. Can you put that? Yeah. Any questions?